What if the labs that are shaping the future of medicine were stuck in the past when it comes to their own operations? This is a paradox at the heart of today's conversation, because despite working at the cutting edge of science, many labs still rely on things like spreadsheets, manual monitoring and siloed systems. And, of course, it's slowing them down at a time where speed and precision have never mattered more. So my guest today is the Senior Director of Products and Solutions at MachineQ, which is a Comcast company. And he's going to help us unpack what's really going on inside those lab walls. From real-time monitoring to AI-powered anomaly detection, Stephen's team is rethinking what infrastructure looks like, especially in environments where a single piece of lost equipment or an unnoticed failure could derail critical research. So if you've ever wondered what the Internet of Things really does in real-world settings, or how labs are quietly becoming smarter without shouting about it, without bombarding your newsfeed with big headlines, you should enjoy this one. So let me introduce you to today's guest. So thank you for joining me on the podcast today. For everyone listening, can you tell them a little about who you are and what you do?
Yeah, thanks, Neil. First off, thanks for having me on. Super excited to join. I'm Steve Corbesero, Senior Director of Products and Solutions at MachineQ. I'm an electrical engineer by degree, product leader, focused on solving real-world problems through IoT and data solutions. At MachineQ, I lead the development of our solutions in life sciences. So I work really hand in hand with customers to understand their operational challenges, and translating and informing our product strategy and delivering, connected technologies that reduce manual processes, improve their equipment visibility and utilization, and just boosting efficiency across all various lab environments.
Well, thank you so much for taking the time out of your incredibly busy day to talk with me. And one of the things that set off my tech spidey sensors was MachineQ. When you, I think it was the Lab of Future survey that you released online, and painted somewhat of a clear picture of operational bottlenecks in today's lab. So before we dig a little bit deeper on that report, what is it that inspired MachineQ to commission that research, and what, or who did you want to hear from when you set out to do that?
I think you have to go back a few years. But, we've walked, or I personally walked, tens of thousands of square footage of life sciences space. And it's clear that managing lab assets is a significant challenge that impacts not only the daily workflows of the end user scientists themselves, but the folks from the lab operations facilities, even up into procurement and like higher levels of the enterprise. So we went to commission the research to really dive deep into the overall state of asset management, which is a very broad topic, but we wanted to focus primarily on US-based life sciences companies with over $1 billion in annual revenue, and then specifically targeting roles in lab operations, equipment and asset management, and maintenance, whether that's facilities or a dedicated service that these types of enterprise have. And that survey really examined a lot of the current practices in lab ops, equipment management, and the adoption of emerging technologies. That's really key to what we're doing at MachineQ. And those firsthand insights really identified areas where IoT solutions from us and others can make a substantial impact. So definitely have a clearer understanding, not only for us as MachineQ and a product organization within my team on what we're building and how that translates to, products and features and outcomes, but also to deliver these insights to the lab professionals out in the world so that they can start, moving on their digital transformation journey as well.
And just looking through that survey here, I think it was nearly 60% of lab professionals have reported things like unplanned downtime due to issues with equipment failures, miscalibration, etc. And it seems that we've been talking about this stuff for a long time. So why is this still such a widespread problem in modern labs, do you think?
I think it comes down to a few things. I think first and primary is a lot of labs still rely on manual or outdated sort of equipment management methodologies. And there's a real lack of real-time visibility into even specifically just equipment status or the location. So without that monitoring and these more manual processes, you're not catching those early warning signs, miscalibrations. These things are often going unnoticed, and they result in disruptions. The second, this is more of a bearing on enterprises or these lab operations sort of level of maturity is how I kind of talk about it is a lot of fragmented systems and data silos. So you have data sort of all over the place. They sit in different teams, and that might be walled off. And that prevents, the labs and the folks managing those labs from leveraging that data to provide more, proactive automated alerting and insights that could help anticipate issues before they escalate. And finally, just like the complexity of the modern lab environment, a lot, the majority of equipment, the more sophisticated equipment is being connected to the local area networks. They're incredibly dense environments. You have hundreds of like high dollar value pieces of equipment within the span of a couple hundred square feet. And some of these campuses are enormous, like not only a single, multi-story building, but multiple single-story buildings, across a footprint, with varying maintenance schedules. It's really, it's a challenge.
And also, with I think it's something like half of lab professionals are still relying on things like manual monitoring, and some with no system at all. What kind of risks are these labs facing that might not be immediately obvious, especially for people listening outside of this space?
I think, especially when you're working off of spreadsheets or more of a manual monitoring model, there's a huge potential for human error or just simply delays. And that often leads to missed maintenance, premature equipment failures, and all of that results in downtime. There's some less obvious risks too. I think without, a really either regimented process with a lot of human capital to throw at it or automated monitoring and sort of that data logging aspect, it's a lot harder to stay audit ready, which I think is really crucial and critical, especially in more of the regulated spaces, to, maintain those records and also investigate issues before they become significant problems. When lab equipment fails, especially, in the dreaded overnights or over the weekend, it's not just an inconvenience to the end users and the lab managers. You could lose critical samples. Some of those experiments, a lot of the experiments run over the evening for multiple hours, even days. And so there's a huge disruption and setback into research timelines. And that's a huge hit for teams working towards a lot of these tight milestones and regulatory deadlines. And so IoT we've seen is helping solve a lot of this by giving labs, real-time visibility into sort of the ongoing processes going on within the labs and in alerts so that they can be more proactive about addressing problems before, they really start significant disruptions.
And the report does show that I think it's 37% are planning to increase spending on lab equipment, but more worryingly, 17% say they lack the data to justify doing that, which is a little odd, especially in a world of AI that can help deliver some of those reasons for data-driven decision making. So what's causing that disconnect between purchasing and real usage insights? What are you seeing here?
I feel like this is the largest part of my job as of recent. I think a big part of that disconnect just comes down to lack of visibility. I mentioned before, these facilities have thousands of square feet of lab space, and that space is filled with hundreds and hundreds of instruments. And if you don't have a centralized system that tells them not only like where those pieces of equipment are, and often some of those, especially benchtop equipment, depending on the size, does move around, and can be shared. We're seeing a lot of movement from the standard, very purpose-built lab to an open footprint lab that's very modular and provides the opportunity to share equipment across multiple teams. So understanding not only where they are, but how often they're being used and whether they're, even operational. Without that baseline, it's tough to make an informed decision. And so they tend to just side with the scientist and make those purchases. Um, we're seeing situations where teams will request new equipment simply because they can't find a piece of equipment. They know they have it, they just have no idea where it is. It might be in storage, it might be in the back of the lab, it might be under a bench. They don't know if there's underutilized equipment even on the same floor that they could just move and make space for something new. And that leads to all the unnecessary spending, not only from like a capital perspective of just purchasing that equipment, but you have to think the total, cost of ownership with all the service contracts, which are significant depending on the type of equipment, all the duplicative purchases, and not only that, but just square footage in the lab space is so prime that if you can make room for a new piece of equipment and remove an underutilized piece of equipment, that's a huge boon to the lab space. I think the last point here is just the data siloing makes it worse. If your data in terms of, equipment location or equipment utilization is on spreadsheets, or it's something where you did a manual time study, which we've seen before, um, there's no way that you're going to ever get a clear picture, even at a single building level, let alone an enterprise. And you have no real chance of sanitizing any of that data to feed it into some sort of AI tool to understand what's going on. I think that's where we're seeing connected solutions really start to help. So consolidating a lot of that data and synthesizing it, but also, working with teams we've seen a huge shift in the mentality of breaking down those silos and either, using off the shelf software or, rolling their own to consolidate a lot of this information into one place.
And I think thanks to things like AI ops, observability, real-time monitoring, we're seeing many industries adopting a more proactive than reactive approach to problems. And yet, again, looking at your survey, only 30% are using real-time monitoring. Yet those who do feel predictably much more confident in justifying their investments. So what are the barriers that are holding others back from adopting these technologies that would essentially make their life easier?
It's interesting. I know you had recently met with the folks from Viva, who are
Yeah.
doing a lot of really great work in AI in the life sciences space. I think from where we are, the life sciences world is embracing AI tools. It just may not be on the lab ops and facility size as much as it is on sort of the more science-based roles. I think the biggest challenges that we're seeing where folks aren't necessarily adopting a lot of these, mainstay technologies and some of the more emerging ones is, I think your typical like pilot purgatory and scaling challenges. A lot of labs get stuck in pilot mode. They test in small areas. The scope might be too small, or they might not be able to really understand the ROI, and they struggle to scale out of that, whether it's due to resource constraints or complexity, et cetera. And that sort of underlining that is maybe, talking about resources, whether it's, a capital expenditure or an OpEx model in terms of how they're going to pay for such a technology, and how that fits in with their budgetary cycles. System interoperability is a big one. If you're not able to integrate the data that you're getting from one of these IoT solutions into your, whether it's a LIMS system or, a centralized equipment management system or even a BMS, it really makes it difficult to really provide that value. And then, of course, data privacy and security. Seeing a lot more equipment being connected to the network. I think folks are still reticent to have cloud-based technologies deployed in the production environment. So it's always a challenge to fight through those.
And predictably, IoT, artificial intelligence, machine learning, adoption of all these emerging technologies is continuing to surge and expected to surge in labs over the next 2 years as well. So are there any use cases that you're seeing standing out or showing the most promise right now? Because we hear a lot around the hype of these technologies, but it'd be great to hear some real life stories and bring it to life and the kind of benefits that it can bring and tangible difference.
Yeah, I mean, I'd be reticent to not mention the work that we're doing, but I think what we've seen and what's most promising is lot of folks talk about anomaly detection in the world, especially you see it a lot in the manufacturing within the life sciences space. That's sort of where we got started is, embedding these technologies, whether it's AI or, more machine learning directly into our solutions and focusing on anomaly detection. And instead of relying on your basic, threshold based alerts that often create a lot of noise and alert fatigue, which further push people away from embracing these technologies, opting for more pattern-based tech detection to surface events that actually matter. And through the course of that exploration and building that into the product, we actually started working with LLM models to synthesize all of the anomaly data that we're actually detecting and summarize that into something that's more useful. And through that work track, we realized that this concept of smart summaries or intelligent summarizations uh, is actually really useful to synthesize all the high volume IoT data that we're collecting for our customers. And that means transforming all that raw data into really clear text-based summaries and visual, basic visualizations that provide the lab managers and the ops teams like actual insights without needing to, dig through reports and manually connect all those dots or fight for informatics resources to analyze that data, and moving labs from being very reactive to being more proactive.
And lab professionals are indeed under increasing pressure and scrutiny as they're challenged to speed up drug development while managing costs. It's quite a fine balance. There's a lot of talk around how things like AI are able to speed up that process. But how are you at MachineQ helping to bridge that gap through your smart infrastructure?
They're certainly under real pressure to accelerate the drug development process and keep costs down. I think that's mainstay for everybody that we talk to. Uh, I think the way that we're bridging that gap is in helping folks bridge that gap is building is making smarter decisions in terms of how you're building out your infrastructure to support all these various use cases that they could deploy, and then scale and adapt that as needs evolve. At MachineQ, that's core, that's really fundamental to the business that we've been building over the last couple of years. And now that we're working in life sciences, just laying that foundation for connectivity within the space that supports a really wide range of IoT use cases. I think if you look at a lot of the legacy products that are deployed today, they're very point specific solutions that are focusing on, fridge and freezer monitoring, or other environmental monitoring characteristics. Whereas with solutions that we deploy, it's could support a myriad of from environmental monitoring to equipment location tracking or even equipment utilization without needing separate pieces of infrastructure and systems for each of those. That sort of single pane of glass. And we've been focused heavily on LoRaWAN, which is a very specific RF technology, but we're increasingly embracing hybrid infrastructures that use the same sort of basic infrastructure hardware that incorporate a variety of other RF technologies. And we're also leveraging camera technology where it fits. But I think what matters most is really using the right technology for the job. We operate within an open ecosystem, so we support both devices that we make and build that we love, as well as third-party equipment from various manufacturers out there in the space that are making really great stuff that passes all of our testing. And that provides us a lot of flexibility to build solutions for very lab-specific needs. And we also integrate, and I've personally been very driven to have an API-first approach to make it very simple for us to integrate with a lot of those, third-party systems that these lab folks already have, and making that very seamless so they can take advantage of it. And then, of course, as the infrastructure matures, layering on all the AI and ML to surface those meaningful insights. I think one of the areas that we've sort of been talking about throughout this conversation is the idea of, how equipment, where it is, but also how it's being used. And instead of looking at or doing time studies, leveraging all the data that you are collecting of all the instruments across your labs or like instruments, and being able to say, okay, take a look at all this data and just spit out to me which ones are being used, like what are the trends, what times are people using them, to try and eliminate bottlenecks in terms of scheduling or duplicative equipment, and making teams faster, more informed decisions without having to dig through all that data.
And in the last 5 years, we've gone from working at home at scale to hybrid working to Gen AI to agentic AI. On the horizon, there's quantum computing, maybe AGI, who knows? All these things are waiting on the horizon. So it could be almost impossible to predict the future. But looking at the next 2 to 3 years, what will separate the labs that thrive, do you think, from those that struggle to keep up with this pace of technological change?
Think within the world of life sciences, there's a variety of early based seed round companies, and then you're very well established like large pharma. I think if you need with each one of those, no matter where you're at in your sort of journey, taking an approach of I feel like this is almost a bad word these days, but digital transformation as a longer term strategy and not just a really short term fix is the basis of how these companies will succeed. Like if you're still working off of spreadsheets, no matter if you're a billion-dollar company or you're, an emerging startup in the space, as you continue to grow and expand, if you're not able to make that jump to a more digital ecosystem, you're going to continue to fall further and further behind. And I think more specifically on the IoT side, labs that are adopting real-time monitoring to automate a lot of those repetitive tasks and unifying all that data and collecting it in a single place, and then applying AI and machine learning as it becomes more integrated within the lab workflows, not only on the science side, but also the operations side, is going to benefit them greatly. If you're continuing to lean on those manual processes and have a myriad of disconnected systems, you're going to spend more time trying to manage and keep those systems operational. And it's just going to lead to slower innovation and difficulty scaling as you kind of evolve. So that digital gap will continue to widen.
Well, one of the things I love about what you're doing is you're someone right in the heart of this space and leading the way with your technology. And I'm curious, so as someone that is out in front, how do you self-educate? How do you keep up to speed with the pace of technology? Because I think each and every one of us feels that pressure. But any tips that you can share on how you keep up?
Yeah, absolutely. I think for me, continuous learning really comes
Yeah.
from a mix of just from the engineering background, just always being very curious and staying plugged into a variety of different sources. Listen to a lot of podcasts, NPR, and How I Built This, and Business Wars. Of course, Tech Talks Daily. I still crack open my copy of The Lean Startup. I've been leaning on that for years. And I also read a lot of email newsletters. TLDR and Morning Brew are probably the two at the top of my inbox every morning. And that's great for just staying up on more of the current trends in tech and business. I was really fortunate coming out of my undergrad to, dive into the startup world in Boston. And I stay connected with a lot of the founders that I work with and some of my colleagues that are from those early startup days that are working in vastly different environments than I am, especially in robotics, AI, ML, other emerging spaces. And those conversations help me stay close to the bleeding edge and sort of dig me out of the day to day in IoT. Um, I think another part of this is a little bit more nerdy, but I also read a lot of science fiction, which I think is an underrated tool for expanding perspectives. Each year, I try to pick a new theme. This year, it's the concept of humans' first contact with another intelligent sort of life. I recently read Roadside Picnic, which really stood out. It's a really interesting take on how alien contact or intelligent contact might be completely beyond human understanding. And that kind of thinking sort of stretches how I look at, product technology and systems design in general. And then at the core of all this, I would just say, as I said before, staying curious, asking why, and really digging in and making time for exploration and that learning. I'm fortunate to have a leader who really actively encourages our group at MachineQ to carve out space for R&D and pushes us to challenge assumptions as we encounter them. And that culture of curiosity is where a lot of that real growth happens.
Absolutely love that. And I'm also going to throw in that book that you mentioned to our Amazon wish list. I think that's something that I'm going to be checking out for sure. And for anyone listening, maybe they want to dig a little bit deeper on that Comcast MachineQ survey. Well, I think it was you surveyed 400 lab professionals. If people want to find that or indeed find out more information about MachineQ and the work that you're doing, where would you like to point everyone?
Yeah, I would say head over to machineq.com. Not only are we really busy in the life sciences space, we do a lot of work in food and beverage and food services as well as hospitality. So if life sciences is in your flavor, we might have something else for you on the website. And then obviously connect with me on LinkedIn as well.
Well, I'll add links to everything to make it easy for people to find you, add the survey and everything we discussed today. And there was a few big stats in there. 37% of respondents plan to increase spending on lab equipment, but 17% admit they lack the data to justify the process, which is a little bit of grim reading. Equally, 56% of lab professionals manually monitoring the utilization of their equipment, 14% having no monitoring system in place at all. But there is so much hope in that survey too. 85% of lab professionals planning to adopt IoT and 87% intending to adopt AI and ML in their lab. So it feels like there's a real transition going on here. And I'd love to get you on later in the year or next year, seeing how things or how quickly things are moving. But just thank you for shining a light on this today.
Yeah, thanks for having me on. Appreciate it.
I think labs may be filled with precision instruments and brilliant minds, but as Stephen reminded us, they're still held back sometimes by the same bottlenecks that plague any industry that's stuck in reactive mode. And the good news is that change is coming, and with 85% of labs planning to adopt IoT and nearly 90% leaning into artificial intelligence and machine learning, we are witnessing somewhat of a quiet revolution in lab operations, one that could speed up discovery, reduce waste, and even future-proof the sciences that shape our lives. But what do you think? Are we finally ready to move from pilot purgatory to full-scale transformation in the lab? Or are legacy systems, and indeed culture and mindsets, are they still the biggest barriers? Let me know. techblogwriter@outlook.com, LinkedIn, X, Instagram, just at Neil C. Hughes. And if you go over to techtalksnetwork.com, you'll find not just this podcast, but 8 of my shows there. And there's even a way you can leave me a little voice message. So pop over there and let me know what you think. Other than that, I'll be back again tomorrow with another guest. Hopefully speak with you then. Bye for now.